So we just finished the 10 and 14 lesson, which was combined. And we may or may not have met all of these learning targets because there was just so many and lesson was kind of long. At some point, we just kind of needed to stop. So let's see if we can recover some of these. So using the shape of distribution to compare the mean and the median. So for example, if I have a bell-shaped distribution, something like this, where would you expect the median to be on this bell shape? In the middle. So whatever number lies there, say it's if you think back to the example we did in class, it was 10. That's usually where it's going to be if it's bell-shaped, because there's even amounts on each side approximately. And then where would you expect the mean to go? Also. For a bell-shaped, it would also be toward the middle. So mean and median toward the middle. Then for other things, let's say bimodal. So the one where it's peaked up here, low in the middle, and then peaked up again. Where would you expect the median to be? Middle again. And then where would we expect the mean to also be? Also the middle. Do you know why? What do both of these shapes have in common? They are the same, just flipped. Here, let me give you one more example. Say I have a uniform distribution. So something where it looks basically at the same level throughout. Where would we expect the mean to be? Middle again. Where would we expect the median to be? Now, what do all of these distributions have in common? It's one other word we could use to describe them. From our list of words. Let's start with an S. All of these distributions are also can anyone describe it to me? Maybe they know a why. They are all symmetric. Good. So when it's symmetric, you can expect the mean and the median to be toward the middle. When it's not symmetric, so that would be our left skewed and our right skewed. So here would be an example of left skewed. Here would be an example of right skewed. Do we also expect the mean and median to be right in the center again? No, it's wherever most of the data is. So we can expect the mean and median to now be closer to here, because that's where more of the data is. And then on the right skewed picture, we'd expect it to be, again, more toward wherever the data is. So here, it's still in the middle, even though most of the data is on the ends, but because it's symmetric, we can expect it. So yeah, you can compare it that way. One thing we didn't cover in algebra, but I might as well tell you now, when you have data that is symmetric, you're going to want to use the mean over the median. Okay, so I've not introduced that to you yet, but now you know. I would prefer the mean if my data is symmetric. If it is not symmetric, like the skewed ones, I would prefer the median. Anyone know why that might be? On these lower parts of our skewed graphs, we expect fewer data points. And what did we talk about today? Like those data points that are away from like the rest of the data. So we talked about outliers. Outliers pull the mean in a certain direction. So like, say we have an outlier on this side, even though most of our data is to the right, it'll pull the mean toward the left, even though most of our data is toward the right, and then vice versa. If there's an outlier on the right side, but most of our data is on the left side, that outlier pulls the mean in the other direction. So that's why the median might be better for those types of data. And I think in this class we've talked before, like those test scores. Say that someone scored a 40, 71, a 73, a 74, a 74, and 100. Where do they score most of the time? In the 70s. But these two outliers, and I'm just guessing that they're outliers, I haven't actually done the math to prove it, but these two outliers might pull it in a different direction, especially when I take one of them out. All right, if I take out this one, instead of his average being closer to the 70s, it's probably now going to be like in the 60s, when that's not actually what they scored, if that makes sense. So just kind of prepping you for the future. That's why we care if it's like mean or median. If it's symmetric, use the mean. If it's not symmetric, use the median. Questions on that one? Okay. So then I can find values that are outliers, investigate their source, and figure out what to do with them. We didn't really have time to talk about the last part of it, investigating their source and figuring out what to do with them. So if I take you back to that example about the grades, so say, we have these scores again. Why might one of the scores been way different than the rest? What could have caused that 40% on the test? Like there's some real world. So not studying, maybe just guessing, maybe you thought it didn't matter that day, I don't know. What other reasons could cause you to fail the test? Randomly. I would say maybe not sleepy, maybe some stress, who knows? But for whatever reason, this person failed one of the tests when you normally score is like in the C range. Now, that could be a reason why when we're talking about figuring out what to do with them, I feel like that's open to interpretation. I feel like, well, if we're trying to say what his average score is, then leave it in there because that contributes to the average. If you want to say what he scores most of the time, then maybe you might want to exclude it because most of the time he actually scores in the 70s. One example that I saw, and I don't know if I have it conveniently around. Let me see. Okay, let me find it. So here, let me just describe it to you because I don't know if I can find it. But one example that I saw that kind of helps like to say if you should exclude it or not. Say that you're rolling a 6-sided die, right? So like what are the possible options of numbers you can roll if it's a 6-sided die? 1 through 6. So if we're gathering data, and this is an example I saw like in the book, say that we got this as this occurred that many times out of this many rolls, but then one of them was a 20. Is it possible to actually roll a 20 with one die? No. So what might have happened in order for them to write that down? Yeah, they made a mistake. Like, I don't know what they did, but it's not possible to roll a 20. on one guy, I guess it's not possible. Maybe they, I don't know what they did. Maybe they wrote it wrong. But then that would be like, oh yeah, totally exclude that value because that just doesn't make any sense. So questions on that? So when to exclude outliers, when not to, it just depends on the situation. Now, I can tell how an outlier will impact the mean, median, IQR, and standard deviation. So we kind of talked about it, but I feel like we didn't tie it together. So when I had that dot plot and I added like a 50 and 100, what happened to the mean? Did it make it increase, decrease, or stay the same? It did increase. Did the median increase? No, and that's just because there were a lot of tens in the middle. It didn't affect the median, but it could. And if it did, we would predict that it increased. IQR and standard deviation, those measure what about the data? Yes, but what does that tell me about my data? Does it tell me like a usual number? Does it tell me how spread out my data is? How spread out it is. So in that case, if you think about that example again, I forget what it started at, but I feel like the numbers were around 10. If I'm adding a number that's 50 and 100, am I making the data more or less spread out? I'm making it more spread out if I'm adding numbers that are way bigger. However, you will definitely see the standard deviation change. The IQR may or may not, because it's looking at just the middle part of the data. Does that make sense? So if I add values to the middle part, then yeah, my IQR will probably change, or maybe not. You'll have to calculate it and see. But if you're making the data more spread out, if you're making the data more spread out by adding outliers, like you can expect the standard deviation to increase. So questions on that? All right, the activities are supposed to help with that, but I feel like today you're really take time to like tie it all together. All right, so now and I need to update this to-do list. Now you have time to work on your practice from today. So there's 2 of them. Shoot for an 80% or higher on both. I feel like that'll take the majority of the time. But if there's time left over, things you could do would be like test corrections, retaking something. I'm going to pass out those box plot foldables that were already graded. If you want to do them or do more on them, right? That's something else you can do. But I feel like that'll take up the majority. So any questions? Yes. All right, so that work on, try to get 80% or higher. If you're not meeting the goal and you use both your attempts, just let me know. I'll give you another one. While you do this, I don't mind if you listen to music, so long as you get this done.